Hi, welcome back to ARISTOTHINK. Today I'm going to help you solve a problem like, well, when you're given a function, find the global maxima and the global minima of that function. Well, so first let's go to our toolbox, and remember, the toolbox is where I give you all the most important parts of the problem, what you need to solve it, and that's going to make it faster than after when we're going to actually resolve the question. So let's just go to our toolbox. So that is going to be our toolbox. That is what you need to know. Okay? Now, the first thing you need to know is this. So the question, as I told you, is going to be like this. Well, find global maxima and minima of f of x. Okay, so that is going to be the problem we're going to solve, and the first thing we need to do is going to be this. Well, first thing we have to check is we have to check how that curve is going to behave. For instance, the curve could be something like this. If it is a straight line, well, the global maxima is going to be this, global minima this one, because it's a linear function. We're just going to see the boundary, agree? Just the boundaries are going to matter. But what happens? Why? And because there is going to be no concern along the way in here. So we just have to check the endpoints, the boundary. But what happens if suddenly that curve goes like this, like this, like this, and this is an asymptote, for instance, and then it continues like here? You see? It's a very weird one. So what would be the global maxima? Well, now you are going to see that to calculate the global maxima, we gotta have the limits. So that is why whenever you find a problem with global maxima and minima, you are going to have your boundary, the limits of that function, because otherwise, well, it depends on the function, we don't need it, but usually they just provide to us the limits of that function. And you're going to see that it's important, because let's suppose that I'm considering the global maxima on this range in here. Well, the global maxima is going to be infinitive, right? And the global minima, well, it's kind of hard to tell, but it seems that it's going to be those points. It must be, they seem to be the same, okay? But that would be the global minimum, okay? Now, what else? Well, now let's suppose that I don't give you that, but I give you that the limits are going to be here. Well, clearly the global maxima is going to be this point, agree? And in the other example, when I thought the limits were a little bit broader, that it would be plus infinity, because it would account for that part of the function. So what I'm trying to tell you is this: be careful. Whenever you need to find the global maxima, you gotta account for your boundary, for the limits of that function, okay, that you're considering. So, and what else? Well, remember, if it is a linear, it's very simple, but what if it's not? And chances are that no one is going to ask you to calculate the boundaries for such a simple thing. There is no sense about doing that, at least not for students. You see, people want to make students suffer, and they will never give you something as easy as this. So never consider about this. Now, not never, it could be, but I doubt that it's going to fall on your exam, something like this. So what are the most important things we need to set when given a function and we need to calculate the global maxima and minima? Well, we have to account for asymptotes. This is very important. So asymptotes. And then we have to account for those points in here. I'm going to change, let me put brown. Okay, here. Enough. So those points, what about those points? Well, in here probably here. Well, what about those points? Well, those points are where the first derivative is 0. You see? You just take your function and you make the first derivative, and what happens when the derivative is 0, the first derivative is 0, is when we are going up, and then, oops, first derivative is positive, almost 0, almost 0, oh, 0, 0, negative, 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 0, 0 again, positive, 0, negative, you see? So in here, the first derivative is going to be positive. At the top, right, the first derivative is going to be 0. In here is going to be negative. In here is going to be 0 again, and so on. But see, so two things I have to worry about: asymptotes, because the function goes crazy, goes nuts near asymptotes, and also near when the derivative, not near exactly, when the derivative is 0. Why? Because at those points you could think that the function was going up and suddenly it goes down. So we're going to seek for those 2 points if there are any vertical asymptotes, and for those it's when the function is not defined, and we are also going to find for the first derivative. Okay, so let me erase that. Okay, so we are clear to go. Let's go. Now let's see. Well, so our first thing on our toolbox is going to be this. Well, first look for asymptotes. This is a Y, believe it or not, and an S. Look for asymptotes. Where? And how can we look for asymptotes? Well, we have our function, and this is going to be, for instance, P of x divided by Q of x. Let's make something more complicated. Well, so what is the thing here? The thing that you need to focus is well, asymptotes are points that are not defined, and because they're not defined, your function goes crazy around those points. So and what makes a point not be defined? Well, the possibility I'm going to tell you here is going to be this one. Well, whenever we divide by 0. So yes, I know that this cannot be 0, but we already studied how can that be formed. Well, so whenever you have the denominator being 0, okay, for all all values of x, that makes your denominator go to 0, that means that that point is not going to be defined. At those points, your function is going to go nuts like this. Okay, so look for asymptotes, and how can you do it? Just take your function and go and find where the denominator goes to 0. Whenever the denominator goes to 0, those points, let's suppose you find that it is at x1, x2, and x3. Good. So those are the points you're going to study later. Okay, first we're trying to collect points that could make trouble in our curve. Now, okay, so this is the first thing we have to look for. Now, another thing we have to look for, number 2 in our list, is going to be, well, we're going to look for whenever your derivative is 0. Why? Because we are talking about those points in here, okay? Where the curve goes in a way, so the boops, it changes. So this is the second thing we're going to do it. I'm sorry. I'm going to put this a little bit up because I need more space. Okay, so this is the second part, and then there is something still important. Oh, and let me put in here. I forgot. So what would be the derivative? Let me put in here. Well, if you remember the quotient rule, right? So it's this. How do we derive the f of x? Well, derive this one, multiply by this one, minus, copy this one, derive this one, divide by this one squared. It's this. So how do we derive our f of x? Well, first derive the first function, the denominator, copy the second, minus, now reverse. We're just going to copy the first one, and now it's time to derive the second one. And divide by Q of x square it. Okay, this is the quotient rule. And what happens? Well, we are going to study only that. Okay. So, oh no, I'm sorry. That was the beginning. Of course. How can we have the derivative being 0? Denominator must be 0, of course. So this one must be 0. For all those points that make that expression be 0 is going to be also points we're going to study. Well, and for last, what should we consider? Well, we should consider this. Whenever you study global, maximum, or minima, whenever you study those points, okay, well, you got to look at your boundary. Those points, you gotta look at those points, okay? And if the function is being defined between that blue square in here, so you gotta look at that point and at that point. Okay, look for the boundaries. Some people, they just study the function and they forget to account for the boundaries. Sometimes the boundary, it is the global maxima or the global minima. Just be careful. Well, enough of that. And now let's go to the proper exercise. Now the exercise is this. Well, we're going to find the global maximum and minima of this function, and the function is going to be, oh, let me reduce this one, no need to do this anymore. So the function is going to be, let me put the paper here, okay, it's going to be 4 sine of x plus 2 cosine of 2x plus 6. Good. Now, this is going to be our function, and of course, if I'm asking you to calculate the global maxima and minima, it means that I must give you the limit. Because it goes, okay, at the plus x and the minus x, it goes infinite. So I've got to tell you the limits that I'm going to study on this limit between 0 and 2 pi. Good. Okay, that is a question. So the first thing we're going to see, remember, we're going to see if there are any discontinuity. So the first thing we're going to find is, are there any discontinuity? Discontinuities. Well, if there are any discontinuities, well, we have to look for them. But I know that there are any. Why? Well, because sine and cosine are continuous function, and there is no denominator involved, so everything is perfect. So I could say that the domain, well, let's first say it's a no. Okay, it's a big no. And if I can explain this, telling that the domain of the domain of f of x is simply the real numbers. So everything can fit there. There is no problem. So we don't have to worry about any vertical asymptotes. Wonderful. One less thing to worry about. And now, let's discuss the second thing. What about the derivative when it's 0? There are some in here, and it's more than 2. So, well, let's derive our function first. So this is going to be f of x. Let's derive. Well, derive of sine is cosine, right? So I'm going to write 4 cosine of x. Now, when you derive cosine, is minus sine. So I'm going to put already minus 2 sine of 2x. Now remember the chain rule. You first derive outside and just go like an onion, going deriving each time into the center of our function, and each time you derive you just multiply. So the first derivation is going to be the derivation of cosine of something. The derivative of cosine is minus sine, so minus sine of that. Perfect. Now let's derive into the second layer. That would be that function, right? 2x. If we derive 2x, is going to be just 2 and multiply it. Well, when you derive that guy, it's a constant, so it's 0. Good. Now, and that must be 0, of course. That is, we're trying to find those places in here, remember? We're trying to find those places. That means that it's only interest to us when the derivative is going to be 0. So if this is derivative, what values of x is going to make that become 0? Well, and this is going to be what? It's going to be 4 cosine of x minus 4 sine of 2x equals to 0. Well, I'm going to divide already. Oh, it's too thick. I'm going to cancel those. I can divide by a constant. A constant can never be 0. You see, you can always divide if you can make sure that that thing is never going to be 0. But sometimes it can be 0. Can you still divide? Yes, but you gotta make sure that whenever you divide by something, you are just throwing away that possibility. So if you divide by something and for some values it could be 0, you are just not studying those situations. So we have to study later. You're going to see what I'm talking about. There is this example covers this. Well, so now what we're going to have, the cosine of x equals to, I'm going to put this one into the other direction, other side, so it's going to be sine of 2x. But if you remember from our trigonometry identities, you're going to see that the sine of 2x is nothing else than 2 sine of of x times cosine of x. You see, this is the double angle formula, if you don't remember. Good. And well, why is that interesting? Because now look what I have. Sine x, cosine of x. You see, some people would say, no, you can't divide, but I will. Why? Because I'm stubborn. No, it's not because of that. I'm going to divide because, you see, I'm going to divide by cosine of x. Why? Because I want to make it simpler. And some people say, no, but cosine of x can be 0. And then he showed to me that, look, this is cosine, this is a sine, and you see, if you look here, the cosine is 0 at those 2 points. I know. So what am I doing? I'm going to divide by cosine because I want to make it simpler. But when I divide by cosine, I am excluding the possibility of x being pi over 2 and 3 pi over 2. I'm excluding those possibilities. I'm being blind. But don't worry, I'm going to account for that later. I'm going to study those points too, in case they are interesting. So I'm going to divide, and that makes what? Sine of x equals half. Well, for that, it means that x can be 2 places. Okay, please. Look. Sine, cosine. If you remember, and I hope you do, we are going to study that point in here, agree? Here. The cosine can have 2 angles, agree? Because it is an even function. So in here is going to be what? Is going to be pi over 6 and 5 pi over 6. So we gotta put the two values. So x is going to be what? Just pi over 6 and 5 pi over 6. Two values. But now remember, when I divide by cosine of x, be careful. When I did this, cosine can be 0. But whenever, at the moment that I decide to divide by cosine, I was being blind about the possibility of that guy being 0. So I have to consider this possibility now. Because I was excluding this possibility when I did this. Because no, you cannot be 0. But now I have to consider this because it could be a solution. And we know that it's going to be what? Pi over 2 and 3 pi over 2. Good. So I have 4 points. That's going to make our function goes like this. You see? This is where it goes to 0. So we have those 4 points. Okay? I have that, and that. 4 points. And I'm going to study all of those. Now, oh, what about the boundaries? I'm not going to use boundaries yet, because now I'm going to the number line. And I'm going to put all the values that I found. And let's put them. So the first one is going to be pi over 6. The second one is going to be what? Pi over 2, yes. Pi over 2, then is going to be what? No. It is? No, yes, pi over 2. Now is going to be 5 pi over 6, and finally 3 pi over 2. Is that correct? Yes, it is. Okay, and now I need your full attention here. Well, this is going to be x. In here I'm going to write the derivative of x. Well, we have seen that at those points it's 0, right? Okay, it's always 0 at those points. Agree? We just calculated that. And now we have to realize what's going on between those. Is it going to be a positive or a negative value? Well, let's find out. Well, how can we do this? Well, we are studying what would be the behavior of our derivative between those points, because at those points it's 0 for certain. Okay, but is it going to be like this? Those are the points that are 0. Is it going to be like this, or maybe I don't know if those are 0. I don't know. How can we be? Well, I don't know. We have to see if it's going to be up or is going to be down. So positive or negative. Okay. Now let's see. What can we do in here? Well, we have to find any points on this range is going to be enough to put the plus or the minus signal. Why? Well, because the function is going something like this. Those points are 0. We found them. Oh, that point is actually like this. I'm sorry. Let me make it. It's not going to be exactly this. That point is this one. That point is going to be this one. That point is going to be this one. And that's going to be this one. Okay, those are the points that have the derivative 0. But now I need to know this. Is this going to be positive? This is negative, negative, positive. See, I have to know if this is going up, going down. I have to study this now. So that is what I'm going to do it. If you allow me to raise this. Okay, so I'm going to study now between those points. I have to know what's happening to our curve, what's happening to f of x. Okay, now I have to substitute that into this equation. Why? Because I'm studying what's going on. Whenever the derivative is positive, the curve is going up. Whenever the derivative is negative, it's going down. And this is what I'm going to just find out. So for this point, I'm going to pick any point that must be lower than pi over 6. Of course, I'm going to choose 0. Well, can I pick up pi over 8? Pi over 12? Yes, we can. But why? Why don't you just pick up just 0. 0 is less than pi over 6, is more than enough. So I'm going to choose 0 for this one. Okay, and if you substitute 0 in here, okay, well, we are going to find, I'm going to put all the values, is going to be a positive. Now, what number can you place between those two? Well, I use it to do my math. I use it pi over 4 because for me it was simpler, and it resulted into a negative. So when I plug it in, pi over 4 into this equation in here, you see, pi over 4 here, pi over 4 here, well, I got a negative. That value was negative, so our derivative was negative. Now, between pi over 2 and 5 pi over 6, I can also use the 45 degrees, so it could be something like this. It could be, you could choose anything else, but I chose that, and that made a positive value for our derivative. See, that line is going to be for our derivative. You just have to plug in that value into this equation, and then here I just use the pi. Okay, it's a very simple. We can use anything, but use something that it makes your life easier. Negative, and then finally, oh, what can you use in here? Just use 2 pi. Plug in 2 pi. 2 pi is easy. 2 pi cosine is 1, right? Okay, sine is going to be 0 here. So all this is going to be 0. This is going to be f of x equals 4. 4 is positive. That is why I put positive in here. So why here is negative? When you plug in pi in here, well, the cosine of pi is going to be -1, and the sine is going to be 0. So this is going to be -4 in the end. So that is why it's a negative. Only this. You just need to know this. Now look. Now we have a little bit. We can imagine how our f of x is going to be. Now I'm going to draw f of x in green. Now it's going to be f of x. Well, you see, going up because it's positive, right? If the derivative is positive going up, then stop. Why? Because now the derivative is 0. And now it's negative going down. Stop going up. Stop going down. Stop going up. Okay? And now we'll have to account for something else. Those are the points that the derivative is 0. Good. And now you just have to do something. Now we're going to plug in those points in the original function to see the actual value. We are almost in the end. You see? Now let's do this. Okay. A little bit thinner. So when you plug in pi over 6 into this equation, you are going to get the value of 9. Oh, I'm going to put all green, okay? I think it makes more sense. So it gives 9. The actual value of our function is 9. What else? Oh, I'm also going to use a 0. Let me put like this. Those are the boundaries, okay? So this is going to be the 2 pi. The 2 pi and the 0, okay? This is going to be the 2 pi and this is going to be the 0 because those are the boundaries. Remember, we have to study the boundaries. Now, when you study boundaries, well, we're going to get the value of 8, if I'm not mistaken. 9 in here, then this is going to be 8 again. And this is going to be also a 9. And now this is going to be a 0. And here is going to be 8. You see, that is the value of our function. Okay, but you see, now I can see what's going on. Because between those two, the highest point is 9. Between those two, the highest point is 9. So, to end, what is the global maximum? Oh, it's too crazy. Maximum. Well, it's going to be just 9. Agree? 9 is the highest value. You pick which one you like, but it's 9. Now, what is the global minima? Minima, okay, is plural, okay. So the global minimum is going to be what? Well, it's going to be 0, not 8, okay. It's going to be 0. Just be careful. Okay, so that's the exercise. Well, 30 minutes. Well, like I told you, my videos are not short. The idea is not to make them short, because the idea is to try to call attention for every single aspect of it. So I just hope you have enjoyed. So in a nutshell, when you have a problem like this, first look for vertical asymptotes. Okay, because if you have one of them, you have to be careful that they are going to skyrocket to plus infinitive or minus infinitive. Now, second, look for the derivatives. Is the point where your curve is going to change direction. You have to understand this, because it's after we found all those 4 points where the derivatives are 0, those 4 points in here, and after understanding the signal of our derivative, plus in here, minus in here, you see? Let me put in here. You see, the derivative is negative in here, the derivative is positive. Oh, sorry, the derivative is positive in here, the derivative is negative in here, because of that signal, okay? That is a signal. So, but we have to understand first where the curve is going to change, and if it's going up or down between those 2 points. And once we understand, we have an x-ray of your function, plug in the values at each extreme, 8, 9, 8, 9, 0, 8, and then you just have to tell which one is higher. 9 is highest and 0 is the lowest. That's it, okay? Thank you very much for listening to my video, and I see you next time. Bye bye.